Planets do not come preloaded with little green men, or for that matter, any life at all. In fact, just the opposite is true. At birth, a planet is not alive. It is sterile, barren, unforgiving. They are born in violence, a demolition derby of colliding rock, fire, and radiation. And yet, here we are. Thank you very much for joining me today. My name is Adair, and I'm honored to present my book, Where Are the Little Green Men? The Adair Hypothesis. This book began as a simple question that has haunted scientists since Enrico Fermi asked it over lunch in 1950. Where is everybody? With 2 trillion galaxies, hundreds of billions of stars in each, billions of years for life to evolve, the cosmos should be humming with civilization. Yet, the sky is silent. No signals, no megastructures, no little green men, just a quiet universe staring back at us. Most explanations for the great silence focus on biology or sociology. Maybe intelligent life is rare. Maybe civilizations destroy themselves. Maybe they're hiding. My book takes a different path. It asks a more fundamental question. What does a planet actually need to produce a technological civilization capable of splitting atoms, building radios, and launching probes? The answer, I argue, is astonishingly narrow. I call it the Adair Hypothesis. A technological civilization can only emerge on a planet that possesses a long-term, stable surplus of chemically and radiologically stored energy that's accumulated through rare, evolutionary, geologic, nucleosynthetic coincidences. In plain English, life might be common, but the energy surplus required for steel, engines, electricity, and science is extraordinarily rare. And that surplus depends on one quiet miracle most of us take for granted: photosynthesis, and the geological luck that turned ancient sunlight into coal, oil, and natural gas. The book takes you on that improbable journey, chapter by chapter. We start with the violent birth of habitable world. Chapter 1 shows how almost every atom in your body, carbon, oxygen, iron, phosphorus, was forged in supernova and neutron star collisions. Our sun formed in a graveyard of dead stars. Had it formed in a quiet corner of the galaxy, Earth would have been a barren rock. Then came Theia impact, the Mars-sized collision that gave us the moon. It stabilized our tilt, created tides, and gave us seasons. Without that one perfect catastrophe, Earth would have spun wildly out of control or frozen. Chapter 2 explores how violence paradoxically created stability. Radioactive decay deep in the core keeps the dynamo humming, generating the magnetic shield that protects our atmosphere. Plate tectonics recycles carbon and minerals, acting on Earth's long-term thermostat. These are not nice-to-haves. They are the hidden machinery of habitability. Chapter 3 is about water, the great fortuitous gift. Earth didn't just get the right amount, it kept it against every force that stripped it from Mars and boiled it away from Venus. Internal water in minerals, plus the late heavy bombardment, delivering heavy bodies, gave us the oceans. And because we walked that razor's edge between too little and too much water, we kept it for 4 billion years. Then in chapter 4 comes the hinge on which everything pivots, the dawn of photosynthesis. Every microbe learned to capture sunlight and store it as chemical energy. But the real revolution, oxygenic photosynthesis, using water as an electron donor, appears to have evolved only one time in Earth's entire history. One singular biomechanical invention unlocked an essentially unlimited energy source. Suddenly, the biosphere was no longer limited by volcanic gases or mineral chemistry. It ran on starlight.